Welcome to The Explainer. Today, we are diving into a technology that promises to shorten one of the most agonizing journeys a family can face, getting a diagnosis for their child. We're talking about the incredible and kind of revolutionary role of artificial intelligence in pediatric medicine. You know, for any parent, there's just nothing more stressful than seeing your child is unwell and not having any answers. And for really complex conditions, that uncertainty, it can stretch into a years-long marathon of tests, specialist visits, and just waiting. But what if we could cut that journey down significantly? That's really the big question we're tackling today. We're going to dig into the latest research to see how AI is becoming this powerful new ally for doctors, helping them diagnose kids' diseases with a speed and accuracy we've just never seen before. Okay, so to really appreciate the solution, first we have to get a handle on the immense challenge that doctors are facing every single day. Take a look at this number, 10.7%. That's how many kids and teens in the US have been diagnosed with ADHD. And ADHD, that's just one of many, many neurodevelopmental disorders that are notoriously tough to pin down. So why is it so hard? Well, the reasons are pretty complex. For one, symptoms can look totally different from one kid to the next. A lot of the assessments rely on subjective reports or just watching behavior. And maybe most importantly, there's a real lack of objective, standardized tools. All of this can lead to diagnoses that are late or sometimes even wrong, which delays kids from getting the help they really need. And this is where AI steps into the picture. Now, let's be super clear about something. We are not talking about replacing doctors, not at all. We're talking about giving them a powerful new assistant, a tool that can spot things the human eye just might miss. So let's look at how these different AI methods actually work. You've got deep learning, which can analyze incredibly complex patterns in something like a brain scan, spotting tiny abnormalities in a premature infant. Then there's machine learning, which is great at telling the difference between conditions that look a lot alike, like certain types of autism and ADHD. And get this. Biosignal analysis can even use things like VR to pick up on physiological signs of a condition that you'd never see just from behavior alone. Okay, that all sounds great in theory, but does it really work out in the real world? Well, the research is showing some incredibly promising results. Get this, one major review looked at 22 different studies and found that deep learning models analyzing brain scans were hitting diagnostic accuracies of over 85%. That is a remarkable level of precision. We're talking about finding subtle patterns that are often completely invisible to the human eye. And this isn't just in a lab. Here's a brilliant real-world example from Boston Children's Hospital. There's a project called Clinical Doppelgangers, and it uses large language models, the same tech behind stuff like ChatGPT, to work like a hyper-intelligent search engine for medicine. It just plows through thousands of medical records to find other patients with similar symptoms, giving doctors this huge well of experience to draw on in a split second. And the goal here? It's absolutely transformative. They want to cut the time doctors spend manually digging through charts by 80%. Just think about that. That's all time freed up for what really matters, talking to patients and making faster, better-informed decisions about their care. But, and this is a huge but, with all this potential comes a massive amount of responsibility. We can't just roll this technology out without building some really strong guardrails to make sure it's safe, fair, and actually works for every single kid. The number one challenge is something called age-related algorithmic bias. To put it simply, if you train an AI on data from adults, it's going to make critical and potentially really harmful mistakes when you try to use it on children. For these models to work, they have to be trained on diverse data from kids of all different ages and developmental stages, period. And yeah, there are other major hurdles we have to clear before these tools can be used everywhere. We have to protect the data privacy of kids, which is a huge deal. We have to understand how these black box algorithms, where it's not always clear how they got to an answer, are actually making their decisions. And we have to make sure these tools are available to everyone, not just the hospitals with the biggest budgets. It all really boils down to this one simple but incredibly important idea. A child's body, their development, their data, it's all fundamentally different from an adult's. And that means we need totally unique ethical rules and special protections built into these systems from the ground up. So, how do we move forward? How do we do this right? Well, experts have proposed a pretty clear path. This isn't just about spotting problems, it's about proactively building the solutions to make sure this tech is developed safely and ethically. One of the best proposals is something called the Accept AI framework. You could think of it as a set of rules of the road. It highlights critical steps like making sure you're accounting for a child's developmental age, not just how old they are, or making sure the way you communicate and get consent is designed specifically for kids and their parents. It puts fairness and data protection right at the heart of the whole process. So when you put it all together, the potential is just astounding. We could move from those long, uncertain journeys to getting fast, data-driven insights, from subjective best guesses to objective decision support, and ultimately from one-size-fits-all treatments to truly personalized care for every single child. And this leaves us with one final and pretty provocative question. We know AI won't replace the empathy and the expertise of a doctor, but as this technology gets woven into the fabric of medicine, will the doctors who use AI eventually replace those who don't? Now, that's a question the entire healthcare world is going to have to answer, probably sooner than we think.